Okay, good evening everybody, this is Mr. Steele. I am back on the video YouTube channel tonight because I feel like I need to give you a few more examples of solving trig equations, since I feel like, especially in 6th period today, it went really fast. So my goal here for these videos is to give you some examples of first the basic kind of trig equations to solve, stuff like the example I have here, then build it up, maybe do one where there's a squared trig function in there, and then build it to ones where the period's different, like we did as an example in class. So starting off, I'm going to start off with a general basic trig equation to kind of get you an idea of what we're doing. And basically here we're trying to solve the equation 2 cosine of x plus root 2 equals 0. And we're looking for solutions on the domain, or on the values 0 to 2 pi. So we only want answers that are between 0 and 2 pi. So to start off with, I said in class that what we're really doing at the beginning is just trying to treat this like an algebra problem. We're just pretending that cosine of x, that trig function itself, is our variable, and we want to get that variable alone. So all our initial steps are going to be in pursuit of getting that trig thing alone. So to do that, it's not going to look very surprising. We're first going to try and get it alone with making zeros and ones. So I'm first going to subtract square root of 2 from both sides. I'll get a 0 there. And 2 cosine of x is equal to negative square root of 2. And then, of course, if we want to get it all the way alone, we have to divide by 2 and make a 1. So cosine of x is equal to negative square root of 2 over 2. And so, yay, it seems like we win. But unfortunately, that's only part of the problem, because as with any algebraic problem where we're trying to solve an equation, we're always trying to get x equals stuff. So we need to find a way to get x equals stuff. Well, in the case of a trig equation, when we see that the cosine of x is some value negative root 2 over 2, we have to picture what that looks like in the coordinate plane. Like, where are the places where cosine is negative? Where are the places, or what are the angles, the reference angles that have a cosine as root 2 over 2? So what we do is we go to our picture. So I'm going to make a very cruddy picture. And then first we have to think about where cosine is negative. So that's my first question, is where could this value be? Which quadrants would this be in? So I start with ASTC. All students take calculus. And now I think about, okay, I'm trying to find cosine as a negative number. So negative cosines would be, let's see, well, all of them are positive here, so it won't be there. And cosine's positive down here, so it can't be there. So we're looking for values in the quadrant 2 and quadrant 3. So let me draw out my triangle in both of these cases. And now normally I would label the pieces, as whatever it is, cosine is adjacent over hypotenuse. But I already recognize that the square root of 2 over 2 corresponds to a 45, 45, 90 right triangle. So I'm going to just right away label my reference angle in here. Instead of labeling it 45 though, since we're given our domain in radians, I'm going to use radians for my label. And 45 degrees in radians is pi over 4. So each of these triangles is a 45, 45, 90 triangle, and each one has a reference angle of pi over 4. Okay, so I realize that's kind of small, so let me just make it bigger. Okay, so each one's pi over 4. Okay, so now, in order to figure out what those angles are then, like what are these two angles that have cosine equal to negative root 2 over 2, I've got to actually look at my picture and figure out where those angles, those reference angles of pi over 4 are in relation to the entire thing. So I think I probably just botched that explanation. Too bad. Basically, what I'm going to do is I'm going to think about where I am. So there's pi. Right in the middle I've got pi. And pi, if I wanted to find a common denominator with these reference angles, would just be 4 pi over 4. So I've used that line of thinking before. Therefore, when I'm trying to find this angle, it's going to be less than pi, or 4 pi over 4. In fact, it's going to be pi over 4 less. So one of our two solutions is going to be 3 pi over 4, because that would be 4 pi over 4 minus pi over 4. And then this one's going to be pi over 4 past pi, so pi over 4 plus 4 pi over 4 is going to be 5 pi over 4. And so it seems, assuming that I haven't missed anything, that my solutions should be 3 pi over 4 and 5 pi over 4. So what I can do to check this is I can pull over my calculator and just see, are there two solutions? Does it look about right? So to do that, I'm going to bring in my calculator. Womp. There it is. And now I'm going to go through and hopefully very quickly, so that I don't run out of video space, graph this thing. So we want to see when is 2 cosine of x plus the square root of 2 equal to 0. So those are our two equations. Now obviously with 0 there, it's just going to be the x-axis itself, so we'll just see how many times it crosses the x-axis to see how many solutions there are. And then to account for our domain being 0 to 2 pi, I've got to change my window to go from 0 to 2 pi. And then again, my scale, all the rest of this stuff probably isn't that big a deal. I'm just going to go from, I don't know, -5 to 5. Just thinking about the shape, it shouldn't be that high. Okay, so let's graph it. It's graphing extremely slow. That's wonderful. And there we go. So, as we see it, if we look here, I've got one solution right there, one solution right there. Yay, there's two solutions. I think we did it correctly. Good job. Okay, with that first example out of the way, let's take a look at a second problem here. So we're going to up the ante a little bit. I'm going to try to accomplish two things at once. I'm going to try to show you two different techniques that kind of come up in here, both of them in the same problem. So I can't promise it's going to work out perfectly. I can't promise I'm going to narrate it very well, but I'm going to try to get two things, kill two birds with one stone. Which, if you think about it, is actually kind of a stupid phrase, because if you used a really big stone and they were kind of small birds, you'd probably do the job pretty effectively, but PETA would probably be after you in that case. So let's go ahead and stop talking about birds and stones. Let's solve a trig equation, because they're more fun and more humane. So, starting off here, I've got this problem, and as we learned yesterday, dividing out things, like your mind might tell you to, is bad. That's evil. No bad, no divide, bad, bad, bad. It's a sin, not a sign, it's a sin, so what we have to do instead is we have to get everything on one side and set it equal to 0 and then kind of factor. So that's what my first step is going to be. I'm going to minus 3 tangent of x over to the other side. So there's not really a nice way to write this over here. So what I'm going to end up with as my equation is 4 cosine squared of x tangent of x minus 3 tangent of x, all equal to 0, because again we made a 0 right there. Nothing fancy. Okay, so now once we get to this equation, we have to look and see what we can do. So we actually have to probably use a Gcf factoring technique. So I see a tangent of x in both of these guys. I'm going to factor it out from the problem. So I'm going to pull out a Gcf of tangent of x, which again sounds really funny to say, but it's true. And then that is going to give me this expression. So basically the tangent of x's are gone. I can't do that. If I could disconnect my fingers here, I'd be okay. Basically the tangent of x's are gone. They've been pulled out. We're left with 4 cosine squared of x minus 3. That was kind of effective. Okay, so from here what do we do? Well, just like when we're factoring, when we get an expression like, I don't know, just throw it off on the side here. When we get like x minus 3, x plus 4 equals 0, we say basically, okay, we can solve this by setting x minus 3 equal to 0 or x plus 4 equals 0. We use the property of zero products. That's the same thing we're going to do here. Basically this gives us two options. Either the first factor, tangent of x equals 0, or the second factor, 4 cosine squared of x minus 3 equals 0. Those are our two possibilities. That doesn't mean there's two solutions. There's going to be a lot more than two. It just means that there are two possibilities here for something being equal to 0. So now our responsibility is to solve each one of these pieces and find out what those solutions are that come from each of these individual equations. So first I'll start with the simpler one, the shorter one. We've got tangent of x equals 0. So tangent of x, we talked about a little bit, is slope. Tangent is slope. And so if we think about this, where is the slope equal to 0? There are other ways to think about it. I'm just using this as one example. Well, a tangent is 0 right here, where sine is equal to 0, because it's sine over cosine, and right here, because again, sine is 0. That means our two angles between 0 and 2 pi are going to be at x equals 0 and x equals pi. So we get two solutions from the first half of the equation. Now, some people ask, well, why doesn't 2 pi count? And I go back to Brandon's method of describing it. Basically, he said that 2 pi doesn't count because our domain here, like the values we're looking at, don't include 2 pi. It goes up to, like soft brackets, it goes up to 2 pi, but doesn't actually touch it. So we can't use 2 pi. So there's one. The next one, the other side, this factor, we're going to get more solutions. In fact, we're going to get 4 total solutions. Like that visual, 4. 4 solutions here. So what we have to do is first we have to do a little bit of algebra. So I'm going to trust that you can follow my steps here. I'm going to add 3 to both sides. Then I'm going to divide by 4. So I know this isn't the most technically sound way of doing it, but I'm trying to save a little bit of time because I know that after a lot of seconds my little camera thing screws up. So that would give me as an equation cosine squared of x equals 3 over 4. And now, of course, since I've got something squared, if we want to get it really alone, we've got to square rootify both sides. That's going to give me cosine of x equals, over here, because we put in the square root, we need a plus or minus. So it'll be plus or minus square root of 3 over 4. Well, that's just the same thing as square root of 3 over the square root of 4. Well, in root 3 we can't simplify. It's irrational. But the square root of 4 is just 2. So we get a much more familiar looking equation, cosine of x equals plus or minus square root of 3 over 2. So at this point we have to actually do some work. We have to come up with where the solutions are. Where are the angles that have cosine equal to positive or negative root 3 over 2? So to start off with, we can draw a little picture over here. Use a little more space, try to make it a little bigger this time. Okay, so where is cosine positive or negative? Well, again, I just kind of find this funny when I do this. So where is cosine positive or negative? Well, all of them are positive up here. So we'll have a triangle up here. Sine's positive up here, so cosine's negative. Well, that's okay, because we need minus cosines. Same strategy down here. Tangent's positive, so cosine's negative. So hey, we'll get one there. And oh, cosine's positive over here. We need that also. And so we get a full bow tie or butterfly or whatever you want to call it. Like, we'll have solutions in each of these quadrants. Now, we need to figure out what those reference angles are so we can find the actual angles. So to start off with, I'm going to label it so the cosine up here in quadrant 1 is root 3 over 2. So that means that if my angle here is x, this will be the adjacent over hypotenuse, and so I get this triangle. The angle x is opposite to 1. That means this is a 30-degree reference angle, which means that one of our solutions is going to be pi over 6. So that's going to be one of our pieces. To find the other ones, I'll use similar strategies to what I did before. I'm going to think of this reference angle as pi over 6. I'm going to think of pi and 2 pi in terms of stuff over 6. So we'll make pi 6 pi over 6. We'll make 2 pi 12 pi over 6. And then we'll just add or subtract the reference angles. So here we're going to be one less. That's going to be 5 pi over 6. Here we're going to be one more. That's going to be 7 pi over 6. And here we're going to be one less than 12 pi over 6, which is 11 pi over 6. Which means that when we combine it with our original two solutions from over here, we're going to have 6 total solutions, including 0 and pi, and all these other guys. So there are 6 solutions to this trig equation. Okay, really quickly before I leave this problem, there are 2 points I want to make. One is kind of a small cosmetic thing, and that is here when I write my 6 solutions, it's good form to write them in increasing order. So if I really wanted to be as good as possible and make me as happy as I could be, I'd write it from smallest to biggest, which is 0, pi over 6, 5 pi over 6, 6 pi over 6, which is just pi, 7 pi over 6, and 11 pi over 6. So that would be the best way of writing our 6 solutions out. So that's one point I did want to make in this difficult problem. The other point I wanted to make came from like kind of analyzing the picture. So usually I like to go back to the graph and see what it looks like and see if it matches. And so here is the graph of those two equations, just to throw it out at you. And unfortunately, just because of the range and stuff, it's really ambiguous whether we really did get 6 solutions or not. When I look at it, I do see 6. I see 1, 2, 3, 4, 5, 6. And then this one, which looks like a solution, doesn't actually count because, again, that would be the one that's at 2 pi. So it's reasonable to assume that we probably got this right. I mean, I could change my window range a little bit. Maybe go from... No, that's not going to work. I have to actually use this button. Okay, sorry, I have to actually use these things. Go from -3 to 3 maybe, and see if it gives me a little bit better picture. So that way it makes it a little bigger. Maybe we can see the intersection points. Of course, it's graphing really, really slow, and I have kind of a sense of urgency and that I want to go to bed. So, I mean, you can kind of believe it, like hit, 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 hit. Like, I think it's reasonable to expect that there are 6 solutions there, and they kind of correspond to what we have. So, again, just as another visual, now we kind of can see whether we got it right or not.